So introduction to unit testing with Mocha and Chai. Mocha is the framework. Chai or the Assertion is the Assertion library you're pairing it off with. So what is unit testing? Basically, it's testing of individual units of code, and this, what I'm going to be showing is functions. By supplying an input that results in an expected output. It's pretty much that's it. You know what your input's going to be, and you want to test that you get the output you expect it to be. So behavior-driven development, what that is it's a methodology and kind of a structure as well. Methodology says to test the behavior of your code, not the implementation. Pretty much it's not how you get there, it's that you get there. What should your function be doing with a given input? Should get, for example, should get the sum of two numbers. That's all you want to know at this time is your input, output, how you get there, what you put in there, what you're doing to a string, an array, that doesn't matter at this point. You just want to get to the solution. So the BDD structure, it uses a set of BDD style methods to create an outline of what the unit of code should do. So this is one of the important things about unit testing that I realize it works as like an outline to like your code being the essay. Here is what you want it to eventually do. You write out your tests and then you get started with the code. So this is the first function that you'll see used a lot in unit testing. This is kind of what you think of as the parent container of your entire test. It's described. So function which holds a collection of tests. It takes two parameters. One is a string, name describing what is being tested, and a function. The function will contain one or multiple tests. So you can see here that what we want to describe is a calculator. Pretty simple, self-explanatory. You want to make these descriptions plain English. You want people who look at your test to know exactly what you're testing without having to guess. Context, this is sometimes used. It's similar to, it's actually exactly like describe, but for readability purposes, they named it context. It's an alias of the describe function, does the same things, but it's used for better readability. So it does the same thing, same string as a parameter and another function. So here is it. It is where you're gonna have your test in. So a function, which is the test itself, takes two parameters, again, a name, a string, which is the name of the test. In this case, it says should get the sum of two numbers. Pretty basic, it's self-explanatory, it's straightforward. And then the function that holds the body of the test. And with the body of the test will hold our assertions. So assertion is the actual test that verify the tested variables result in the expected value. So it can throw an error when things aren't correct or right with the test, or it'll throw an exception if your test fails. And this is the assertion we're going to be using mostly in my examples here. There's a couple other ones, but I really like this one just because you're pretty much telling it the exact value that you want to get. So it's called expect, BDD style assertion, where you can chain natural language assertion. What I mean by that is after you see expect and then the function add 5 and 3, 2 and equal. It's just plain English. There's a lot of other words like this that you can use that you'll see that make it so much easier for you to understand what you're testing and for any other person who by any chance has to come up to maybe refactor your code or help you with your code, they can see exactly what you're doing. And then here you can see that we just created a function, add, and then two parameters, 2 and 3, 2 equal to 5. So pretty much we wanted to get some of those two numbers. Same thing here. This is, by the way, this is the first thing you want to do before you even start coding, is you want to write your test. So why is unit testing important? Quick feedback loop. Multiple use cases can run very quickly as opposed to manually testing. So you can have a whole bunch of tests and have it at just the click of a button, execute all those tests and get you all the feedback you need on various parts of what your function should be doing. You'll see it immediately rather than having to console.log every other line. That's just extra code, and it takes a lot longer to then have it run in your browser. Then you can see the console.log. This in the terminal is just instant, and you'll see red, failure, green means good, and then you'll see blue for pending. That means you haven't quite finished that test, writing it out. Next is develop without fear. So without any test in place, how confident are you that your changes won't break something? If you do break something, you may not find out for days, and by then, what was the change that caused the break? So I don't know about you guys, but me, I can step away from my code for maybe a day, come back, and I've completely forgotten what I was doing. I have to read line by line. I don't remember what I was thinking, what I was trying to solve. So that, then me trying to go back to it, I might just break something because it was something maybe I tried before, didn't remember, and I did that. And here, because of the quick feedback loop, you immediately know if something else that you were testing for broke from the beginning, because trying to get to a solution that's a little more complex. So here you can have a chance to then go back and tweak to then get those tests passing again. Modular and readable code. So unit testing forces you to break things down so that they're easier to test. This is what helped me in my code cap. I was constantly in a panic because I wasn't figuring stuff out. I was trying to figure it out in my head first, and this forced me to really just put it down in a test with exactly what I wanted my function to do, what I wanted it to do in the beginning, to then get to the next step to finally get to a solution. So it helped me pretty much clear up my thoughts. Can lead to writing functions that do one thing really well instead of large chunks of code that have many responsibilities, cleaner code. So you want that one function to do adding very well, and that's it. If you want to start to do subtractions, start another function. Don't have them do both things in one function. Faster bug fixes. Getting an immediate response to a well-named test, you already know what you broke. Removes any guessing and cuts down the time of investigating the cause. So again, you don't have to use console.logs, then run it in your browser, and then see what's printing out, then go back to see what console.log this was for, that was for. Write a good name, very descriptive, and you already know what failed. And documentation. This one was kind of a realization for me as I was doing this presentation, and this makes so much sense to me. By using names that are explicit, descriptive, and concise, you can provide great documentation, misspelling that, don't worry about that, for what the code is supposed to do. Makes comments in the code unnecessary. Forget about commenting in your code. Have all the information in your tests. People who have to work on your code later, simply just go to your test. They read what you're doing. They can get an idea what your thought process was, how you got to your solution, and how they can then add to your code. And by the way, if you guys currently maybe don't work in the industry, documentation is very important. Oftentimes you'll come up with a problem that maybe 10 people have already come up before you. And by having it documented, you're already saving so much more time for you and your coworkers. So anything that will save time is always a plus. All right, so we can write some tests now. Let me move this over here. Actually, let me move this back for just a second. All right, let's have the terminal here first. All right, so we're going to be using the terminal at this point here because we do have to install some things. Let me try to minimize this a bit. Oh, too much. Sorry about that. Okay. There we go. Okay. So we want to install the following in order to do this. So we'd be testing in Node.js. So that's through the terminal rather than the browser. First, we'd be installing Homebrew. Makes it easier to install Node. Then we can brew install Node. Then we're going to create the following. So it's a directory for the tests. Pretty much make their tests, a file for your code. So let me actually do that now. I've already got Node installed. So test one. All right. Okay, we're in there now. So the next thing we're going to do is make the file for our code. And then a file for our tests. So you want that in a separate file. You want to have test.js. You'll see in a second why. All right. Okay, then we want to have a package.json. So by doing that, we just do npm, which is installed with Node. Why? We just want to go with the default. Immediately have to do everything for us. And next, we want to install Mocha itself. So we can do that by doing npm install. --save -dev. So we're saving it as a dev dependency. And you'll see that come out in a second. So it shouldn't take too long here. Okay, we got that in there. So now the next thing we want is chai or assertion. Same thing, npm install. Save chai. Okay, so we're just about there. All right, so now what we're going to do is open up our package.json. Let me just open up this here. Here you go. So this is pretty much everything we created. We've got our index.js, index test, package.json. Close these block lines. All right. So here what we want to do is add to the script here, where you see test, what we want to add is this value here, which is watch, and the value of Mocha W test.js. So what this does is it's one of the things that really saves you a lot of time. By including this script, you're going to have any change that you make to your test or your code. As soon as you save it, it's going to rerun in the terminal and immediately rerun all your tests. So you don't have to do anything. You have to go into your terminal, run the test yourself. Any change at all, it'll rerun it. That W flag is what does that magic. And the reason we want to name our test file with test.js, what this script is doing is it's saying to watch any file that has this .test.js. So you can have other tests with this name there and it'll run everything. Okay, save that. And now we open that up. Now we can just run it now. Run watch. That doesn't look good. Oh, did I? Thank you. By the way, Tim, he was one of my teachers at my boot camp, so if I seem a little nervous, that's why. All right.
Make it a little bigger.
Sure. You want the which part bigger? All right, so 0 passing. So it's already thinking we're testing something, which is good. Let me, all right, so I'm gonna have it down there. So you know what? Do we have a plug around here? Because I'm just noticing my battery's dying. Okay, so we want to start with our tests. So basically, we're going to start with that structure you saw earlier. So let me actually just get started with that. I'll put this down for a second. Okay, guys. So actually, what we first want to do is we want to import our file and we're going to have our functions. We haven't written anything yet, so we'll hold off on that and go to requiring both Mocha and Chai. So we make a const. We're going to use some destruction here. So we'll be using expect. Maybe an assert. And require. Try. Okay, and we also want. Actually, we don't need that. Okay, we're good. So this is pretty much what we got. Is our assertion library. Now we can start with describe. Well, the describe is pretty much what we're using as an example is the calculator. We'll use a simple function for that. Okay. The function follow. Oops. Follow. General syntax. Okay, so now we've got our container. So following this, we want to do a context because it's not the actual calculator we're doing. We want to test the adding. So context. Follow that.
You use command plus, it'll make everything bigger.
Yeah, the font looks a little small.
Oh, okay. Sorry about that.
Would you, can everybody hear him without the mic?
Hey, can you hear me without the mic? Is this loud enough?
You want to
Okay.
type with both hands.
Yes. Thank
You chair.
you. Sure. That'll work. Okay. Okay, so thank you. So now we get to the it. The it is where we're going to actually have our test. So we can start with something basic, which we saw earlier, should get the sum of two positive integers. Okay, same thing there. All right, and now what to expect. So we want this function, which we're going to call add. Take the parameters. Oh, thank you.
Whatever it takes.
4 and 5, and we all know basic math, I hope. And that's going to equal 9. So to equal 9. And that's it. We've written our first test. That's pretty much how easy it is. We're pretty much going to get to a point where you're just going to do that over and over. We want to save this. And we see in the terminal here. No. What's the terminal I have? There we go. Okay. All right, cool. So still 0 passing because we have nothing yet. So now we want to open up our actual code. Now we want to start. So what we're going to do is create that function, add x, y, 2 parameters. And basically now we just figure out how we're going to solve that problem. So real easy, x plus y, return that. Save that. And we want to export it as well. There. So we want to export this function. There we go. Actually, I can close this now. Save that. Now we're going to import that file. Add right. Okay. Add module.export. Sorry, I have a little difficulty here. Module exports. Module exports add. Equal. I should do that. I'm missing anything. Tim, you got any suggestions? Oh, thank you. All right.
Good catch. Let's also fix up that arrow. Yep.
All right.
There you go.
Here we go. Yeah, why isn't this? Not the wrong one. This one right here. Let's minimize that there. So what do we got here? Shouldn't I have this run one? Yeah.
On line 5, you're going to want to assign add direction module.exports instead of module.exports.net.
Okay, so just forget that.
And then you might want to just restart MochaJS so that it's
Okay. All right, there we go. Sorry about that, guys. So we got a passing test. So it's linked, it's wired together with module.exports. We got add, and over here we're requiring it with const add. So now it knows that this function is connected. We're getting these two parameters here to equal to 9. So now you want to say you want to make a robust calculator. You want it to do just more than add two things. So, or you actually want to check also that it can do maybe negative integers. So now we go on to another it. Expect, let's say -8, -2. And we should be getting -10. Save, and immediately we get the result there. So we get 2 passing. You see the green check marks, and you see the check marks next to what actually you're testing. So that's what makes it easier. That's the quick feedback loop that gets you your response. And if you ever break something, you know what's breaking and what to address. So by now, maybe you want to start getting maybe a little more complex. You've kind of done the basics. You want to do maybe something else like, it's a little difficult here. Maybe add a percentage to the sum. So another it. Percentage. Okay, so we should expect here add all right, so I left it this way because now we want to think what exactly do we have to do in order to get a percentage plus a sum of 2 integers. So that kind of first tells me that now we need 3 parameters. So if we need 3 parameters, we got to change our code. First, let's kind of add what we wanted to do. So let's make the first one the percentage. We want to add 10% to the sum of 5 and 15. So sum is 15 is 20, 10% of that is 2, so we want to expect 22 now. Okay, got the test, so this is good because we haven't written it, we're failing it now. So let's go to our code, so we can figure that out there. So, okay. So I kind of already have this written out. I was practicing this yesterday, and let me tell you, I definitely need a lot more practice with JavaScript. Seeing that I went to code school for JavaScript, and my first job I have to do Java. So I guess that's the way it works sometimes, you know? So let me just copy this here. Put it over here. So you can see just how it went from that to something like this. And I used kind of like real vanilla JavaScript because another plus about unit testing is you can then fix your own code, refactoring it, and finding better ways to do it. So like I said earlier, the more important thing is getting to a solution. And that's what you want to focus on. It doesn't matter how you get there. If you have like 3, 4 loops, as if it gets there, now you know what the logic is. And then you can look into MDN, look for other methods that do the work you were doing very granularly, and then learn from there. So that's how I learned a lot. I don't know if you guys know Code Wars, but in Code Wars, you were presented with JavaScript challenges or any other language. It's whatever your choice is. And pretty much what Code Wars does is this. It writes up a lot of tests ahead of time, tells you what it should solve, and then it runs your code through its own tests, its own assertions. And that's how I learned a lot, actually, with my unit tests, because when I would go to Code Wars and I was presented with this problem that I thought I found a solution. But when I submitted my solution, it said it didn't work for this, this, and this. So that helped me because then I went ahead and created my own unit tests for those conditions that I failed. And doing so, then I ran my code, made it pass in my own unit tests, submitted it, and then passed the test, went up a level, felt great, you know, felt amazing. And let's see there. Okay, maybe not. Let's see what's missing here. Ah,
Yeah, your function's name addition.
yes. Too many letters. All right. So this logic now works for all 3. So pretty much what I have to do is, because I wanted it also to pass for just 2 parameters. So that's where you can kind of challenge yourself. At first, I could have just added a 1 for the first parameter and just used 1% or 0 and made it easier for me. But I really wanted it to work just for 2 integers and then 2 integers plus a percentage. So that's kind of what pushes you to then improve your code, figure out a solution. And that's why I believe like unit testing is what helped me in my bootcamp, because it got me to think differently. It got me to think more granularly. And instead of jumping to other, trying to solve bigger problems, it helped me break them down into even smaller problems, more manageable problems. And I would suggest that if you're creating your own unit test, and let's say your first test, it seems to be just too difficult, then break that apart into 2 other tests. You know, go as small as you have to in order for you to succeed. You can do anything, you can test whatever you want. And I'll admit that when I first started unit testing, it got pretty addicting because it felt good seeing all these green check marks. So I was just writing a bunch of easy tests because I want to see a whole bunch of green check marks. But you got to be careful with that because then you're kind of testing the same thing over and over. You want to push yourself, kind of like what I ended up doing with the solution for this here, is find something that's just harder, but you'll know that you have the feedback to fix it if stuff starts breaking. Let's see what I got here. So that's kind of a sample of it. Get that. And I wanted to just talk about that Mocha and Chai is just what I've shown you today. That's just a little bit of it. There's so much more you can do, but there's also other testing frameworks called Jest and Jasmine. On my project that I'm currently QAing at Ticketmaster, they're using Jest because they're using React. So if you're into React, you may want to think about going to Jest. And I know there's Jasmine that kind of integrates with Angular 1 and Angular 2. These are just 2. There's still a whole bunch of other ones that you can use. Cucumber's one. That's actually the one I use at my place of business because we're using a Cucumber, Gherkin style syntax with Java, Maven, a whole bunch of other stuff that I didn't go to coding bootcamp for. So here's an example of it. Let me see if I can actually make this bigger. Nope, not doing it. Okay. So I wanted to show you this because this is an example of a jest test with React. And you can see the similarities described here, expect, test. It's very much this very similar structure. So it doesn't matter if you start with Mocha and try assertions. It's like a step into other testing frameworks because they're pretty much almost the same thing. You're just doing it a little differently. Here is an example of Jasmine testing Angular. So again, you see a very similar structure. Testing a different JavaScript framework, but still it's almost the same thing. Actually that's it. So that's the end of my talk. Hopefully you guys are encouraged, if you haven't already been unit testing, to start doing so, because I believe that it doesn't matter what level you are. You could be an expert if you're not unit testing. First of all, shame on you, because you should know better. But if you're like in a coding bootcamp, you just got out, you're just starting out, this will definitely help you get to your solutions that you want, because in the end, it's not really how good you are at writing the code, it's that you're a good problem solver. And to be a good problem solver, you first have to know what the problem is. And with unit testing, you can lay it out all on the line, get a good organization for it, and it keeps you organized as well. So it doesn't have you hopping around thinking, well, what about this, this, and that? No, you solve the first problem, and then you go to the next. So that's it for me, guys. Got any questions? Yes?
So, how would you create a test for a function that doesn't return something?
That doesn't return something. That's a good question. I think there's, actually let me show you. There may be an assertion for that. I can't tell you for sure. I just know that there's a lot of assertions for different things, such as even throwing an error. And if you go to the Chai assertion library, you actually see a whole lot of examples of what you can and can't test. So the assertion we used here was expect. So obviously we have to return a value. But there's also other assertions that will test whether it's something, it's a string, a number. I'm not too sure about that. I think I'm going to find that out tonight, see if I can answer that question. But I'm sure it's somewhere in here, and I'm sure there's probably a way to test that. So I already have a solution for you, an answer for you, but yeah. Anyone else? Anyone going to start using unit testing now? All right, cool.
I have a question.
Yes.
So do you write the test before you actually write the function, so you can look at what you're trying to accomplish?
Yeah, so it's almost like I mentioned earlier, your unit test is like an outline to your essay.
Right.
So you really pretty much want to write out and then get the idea of what you wanted to solve. And how we were doing it earlier, I mean, we could have gone forever, I think, with this, right? So it's up to how much you want that function to do something and how well you want it to do. It's important because if you start writing the code, then you're going to get stuck there. You're not going to want to go back to your test anymore. And it's happened to me a lot of times. You start writing the code, you get into it, you get in the zone, then you start console.logging, you're like, that's it, to unit test, I don't want to do that anymore, I'm already deep in the code. It's better to do this because it organizes your thoughts. It forces you to slow down, in other words. So sometimes you want to start coding and you go too fast. And you just start throwing code in there. And you just start breaking more stuff than you start solving. So by doing this, you force yourself to address one problem before you get to another. And then build up from that. Get as complex as you have to after that to make your function very robust. Make your function add whatever is thrown to it. So it becomes a function where you can then just use anywhere, because you know that one function is really good at one thing. So yeah, always start with your test first. It's a little difficult at first to do that because you're programmed to just want to code. But again, this forces you to do something you don't want to do, just slow down. And really think about what you want to write and what you want to solve. Your question? Yes?
I have an answer to that. That's called TD. He was starting with TD behavior. It's kind of called
Test-driven development.
So we just sort of
for your development function, so that your whole goal as a developer is to pass that test. So if that test is really well written, that's accomplished. You know, when it passes, it accomplishes your goal that function. And there's different camps. It depends on how they want to tackle it. But that is one approach.
Cool. Anyone else? Yes.
So as mentioned, you see your take master, right?
Yes.
Do you, is your role there primarily just writing testing? Do you write testing for pre-existing code, for features, or is this like?
Currently in the project I'm in now, so I'm not actually doing unit testing because I'm actually testing the front end of what the developers are creating. But in my project, yes, I'm doing everything brand new because it's a brand new project. So I literally have to create brand new tests from scratch. But there we use a whole lot of different things. We use Cucumber, Maven, we've used Selenium, WebDriver. But it's very similar to this because we use, it's a lot of the same logic.
So are you guys doing test driven development?
What was that?
Test driven development there then also?
Yes, yeah. So that's how I knew that Jest was good for React because developers are using Jest for their unit testing. So, anyone else? Yes.
What are some good resources, or how did you learn to write better tests or more clear and explicit tests?
I just kept writing them, and I kept looking at examples of, that other people used. So let me see if I have an example of a very old test that looks very bad, but it really helped me. It was actually for a Code Wars challenge, right? And let me enlarge this here. So this was for a Code Wars challenge that I was pretty proud to solve, which is called Street Fighter Selection. I don't know if you guys know what Street Fighter 2 is. But pretty much what you would have to do. Sorry? Oh, sure. Sorry. Put people in back. Cool. So this is actually my solution. This was a long time ago. I just saw it again the other day, and I realized just how much of a mess it is. But I solved it, and it was a very difficult problem. Pretty much, it was mimicking the behavior that on the Street Fighter 2 selection screen, you have 10 fighters, and whatever direction you input, it would move and then output the fighter it was now hovering over. The thing was that in that menu, in that selection screen, if you hit left on the farthest left fighter, it will go to the other side, and vice versa. Now, if you go up on the top fighter, it doesn't do anything. So you have to output the same fighter again. That was a little tricky, but because I was able to unit test, and you can see that's a disaster too. Clearly, I should have used one describe instead of multiple describes of the same thing. Could have done this globally here, and then did every single thing. I kind of got, a little carried away. I started doing everything here, but it worked. I mean, here you can see that by going left, left, down, down, left, it was supposed to equal this output here. And when it started solving, then I just wrote a bunch of other ones that I knew were going to pass just because I want to see all those green check marks. But yeah, I mean, you just got to keep writing them. Like I said, this was maybe less than a year ago that I was writing this code and these tests, and I write it so much differently, more efficient, because you got to make it easier for yourself. Like, you got to come back to this one day, and I did, and I was like, what the hell was I thinking? But this is how you learn. And I think also being considerate that one day someone else is going to look at your code, you want to make it easier for them. And you want to make it easy for them and hoping that someone would make it easy for you. So I think that's one thing that motivates you to write better testing. And again, like, seeing other people's code is always another way to learn. Like, you see what solution they did, and you're like, oh, I didn't think about that. Same thing with the test on how you write them. So. Anyone else? Yes?
Have you used testing to test how JavaScript is outbound?
I have not. I know it is possible, though. I have seen it, and I may have done it in the boot camp. I don't remember, Tim, if we did that. but I believe that is possible. I don't know if it's with Mocha. Might be one of the other testing frameworks. Like I think Jest does test like the components that are rendered in the display. So that's probably one framework you're interested in if you want to test that.
So questions are how to test the websites.
Like testing like for the DOM.
So we use Selenium with MochaJS.
Selenium with MochaJS.
We'll automate some clicks and grab things from the DOM.
Oh, but I think you were asking about whether they're getting rendered or.
Yeah, like if they're getting rendered correctly.
Oh,
At
okay.
that point, it would be like quicker to look directly at the website.
I see what you mean. So just the rendering part. I know the UI part. Yes, you can use Selenium with Mocha, which I have.
Selenium can also check if it got ready.
Okay. All right. Yeah. Cool. So Selenium. Thank you, BJ. Anyone else? Good. Cool. Thank you for having me, guys. Appreciate it.